Let's examine the code more closely. We will cover 4 separate topics. First is BSS DBS modules, which allow connections to various database types, SQL or NoSQL. Serializer class, which will allow us to store and retrieve objects, which could be a dictionary, could be a data class, or could be some really complex object inside of these databases. BSS Adapter External DB, that's an abstract class which implements a generic interface, providing a service when user data is stored in some external database. And then finally, specific BSS 3CX adapter, which extends BSS Adapter External DB class and implements functionality which is related to 3CX. Why do we need these database adapters? We already saw an example when we were doing REST API calls to external systems and we didn't need any special adapters. Well, the idea is we want to keep our code which implements a business logic, for instance, decides how to do user authentication or how to do other things. It should be clean and it should not depend on how exactly user information is stored, because, well, maybe today it's stored in MySQL, tomorrow we decide to migrate the same database to Google Cloud Spanner or something else. And we don't really want to go and change the logic of our authentication code. We will just replace a connection module which will allow us to retrieve that information from new database type. And this way we have our BSS adapter which retrieves standard objects through DBS modules, which then in turn use specific API, whether for MySQL, Firestore, or some other database to retrieve that information. Let's take a look at the code now. So BSS DBS, and that's our main module. We have a class called TideKeyValue. The name is a tribute to my many years of programming in Perl, where there was a concept of tide hash, which is kind of like a dictionary, but which is storing data not in memory, but in something else. And it provides a standard set of methods, and by default, it does store the data in internal dictionary. However, it is also implementing a lock, so it's multi-thread safe. If you have several threads modifying the data, there should be no problems there. And the idea is in your classes, it's not going to be dictionary, it's going to be a real connection to the database. So we have to implement some, or override some internal methods, such as get item. This is something which is called when we, in our code of BSS Adapter, attempts to access a dictionary value by its key. Get method, probably well familiar with it. Pop, set item, and we implement what exactly happens when a value is assigned to a specific key in the dictionary. Delete item, check whether a dictionary contains a certain key, iterate after all keys of a dictionary, check length, return all the keys or items. And here's the implementation of Firestore key value, and you probably saw it in action already in our other examples. It's when we need to store some collection of objects in a local file. Very efficient when we're just doing some local debugging, but of course not very good for production. And if we take a look at the Firestore module, it extends our TideKeyValue, but now what it does, it of course uses Google SDK for Firestore. When an object is created, it retrieves the credentials from environment variables and establishes a connection to the database, and it will connect to certain collection in that Firestore. And then we have methods which allow us to pack and unpack objects from the format stored in the database. In case of Firestore, it's basically a collection of key values pairs. So we can easily put there some normal values, but in case if we have something more complex, for instance, datetime object, it does need to be packed properly. So this function, it uses Serializer Module, which ensures that our object can be stored in external database. And then the same methods which we saw before, for instance, get item, retrieve a certain element, but now we actually retrieve a document by its ID, and if the document exists, then we retrieve the document, all the fields, and then convert them to specific object. And so on with the other method which we need to override. So we have less than 100 lines of code, and we are ready to use this module to have our data stored in the Firestore. And just a quick note about Serializer. As I said, the idea is we may have some structure of database where we cannot just put object directly. So we have several subclasses, such as, well, scalar just writes value as is, so it's good for simple objects such as string or number. For dictionary, also we can just store it without any additional complications. Then we have Serializer data class, which allows us to store data class object as set of values, but when retrieving it, it will actually produce an object of a correct data class, so we can use it as a proper data class object in the rest of Python code. And Serializer object, it uses Python Pickle, which can convert pretty much any structure and store it. The only disadvantage is it's stored as a long byte string, so we cannot really analyze the value when it is stored.